This video is just going to be some miscellaneous problems from the practice sheet, mainly sums and differences of cubes. There's a few squares in here, and then factoring by grouping, which you can recognize when there are four terms. They don't hide it very well. So we'll start out with a factor by grouping. I see there's four terms, so I immediately want to check to see if there are two terms that are lined up that already are like have a common factor. So I can take an x out of here, and it leaves me with 3y plus 4. Then you just want to take a look over there and say, can I take out something there to leave me with 3y plus 4? Usually it's just the common factor. Sometimes you have to change it. So if I take a k out here, then I'm left with 3y plus 4. So now I combine, and I basically am factoring out a 3y plus 4 out of both of these. So if you take x times 3y plus 4 and you take k times 3y plus 4, that's the same as x plus k times 3y plus 4. So pretty standard for the factoring with four terms like that. You could get a little trickier. There's another one that's a little trickier. The other thing that can happen that you got to be careful of is when there's a negative. Again, so I'm looking at this and I go, oh, maybe it's a cube. No, it's not a cube because I have four terms. So I'm going to use my grouping strategy again. So I'm going to try to group these two. I know I can take a p squared out. Leaves me with 2p minus 5. And then when you look here, I can take out a 7 out of both of these, but that would leave me with negative 2p minus 5. So instead of 7, I'm going to take out negative 7. General rule to get the, so I take that opposite sign, so I get a 2p, negative 7, makes out a negative 5 as well. Again, if you multiply p squared times 2p minus 5, multiply negative 7 times 2p5, it's the same as multiplying p squared minus 7 times 2p minus 5. This is just the distributive property split up and put back together. So this factors into two binomials. Let's go to one like this. So I look at this and I was thinking, I learned the difference of two squares, and your immediate thought is to think n minus 2 n plus 2. But this is the sum of two squares. So this is prime. We actually can't factor this with real numbers. We may do it with imaginary numbers later on, but that's prime. That one often gets people. And that's a review from yesterday. Let's do a new one. Let's do a cube. So I'm looking for something that has two terms and that I think they're both perfect cubes. And so looking here, and I think, okay, I know 5 times 5 times 5 is a perfect cube, so 5x, because 5x times 5x times 5x. 216, I'm not sure, and there's a chart I could print for you, but you have a calculator. If you want to know if 216 is a perfect cube, you go 216 and you raise it to the 1/3 power, which we learned was the third root, it's a cubed root. Sure enough, that's 6. So I have 5x and negative 6. And so then I refer to my rules for cubes. And the rules for cubes, you always subtract. And then for a difference of cubes, I'm going to always subtract my two terms. And then I'm going to, so if this is, we call this a and this b, I think that's what our formula sheet had. So this would be a minus b. And then it's a squared and b squared. And then the middle term is always opposite of what this sign is. Outside's the same, middle term is opposite. And it's just a times b. So now I can just plug in my number. So this is 5x minus 6 times 25x squared. I'm going to put 36 here. And then 5x times 6, which is 30x. And this is a formula that you memorize kind of when you're doing the problems. You'll probably forget at some point. when you're done doing these. So you can always help yourself out by checking and seeing if your answer's right, kind of working backwards and from what we did before. If I distribute here, I get 125 x to the third plus 150 x squared plus 180. This is minus 150 x squared minus 100, oh, I forgot to write the x on that 80, minus 180x minus 216. And so you can always check if you forget, did I get the sign in the middle? Did I switch it? Keep it the same? If you add these up, these are gone and you end up with what you started. So you can always multiply it back out when you're factoring. You know whether it's right or not. Okay, let's do another difference of cubes, or a sum of cubes. I see a sum of cubes on here. Right here, let's go to number 9. So there's a cube there. I look at this and I see they're not both perfect cubes though, so it doesn't fit my formula right now. But I remember that when I don't know what to do, I always can factor out the greatest common factor. Now I do have a perfect cube, which is A, and a perfect cube, which is 2. So I'm going to follow my rule for addition. We just did the rule for subtraction. The rule for addition is A plus B, A squared minus AB plus B squared. So this time my A is actually an A. Don't forget the 4 with your answer. Just goes out there hanging along for the ride. So A plus 2, A squared minus 2A plus 4. And again, if you want to multiply it all out, check it, you can. Don't really want to do that right now, but you could distribute that. Essentially what happens is the inside part gets canceled out by your formula. Flip it over to another one. Now let's look down here because this is sometimes tricky. 4 terms. In these 4 terms, I'm thinking factor by grouping. They were all nice and lined it up for us. So I can take a 6v squared out of here. And it leaves me with v plus 7. And then I go over here and I see a v plus 7. You still are factoring out something or multiplying this by something, and that something is 1. So there's a v plus 7 times 1. And again, if you multiply 6v squared times v plus 7, you multiply 1 by v plus 7, it's the same as 6v squared plus 1 times v plus 7. Let's do another cube. So this is a difference of cubes. Perfect cube, we already found that one is 6. Perfect cube is 1. So your formula helps you out. So 6x minus 1, 36x squared. So you square the first, square the last, multiply the 2 together, and in a minus, the 2 inside are plus. So that's going to be 6x, which is 12x. And so if you don't believe it, you're not a believer. It's not 12x, it's 6x. If you don't believe it, multiply it out and check. So negative 36x squared, negative 6x minus 1. The minus 1's good. I need to get 216, got it, and 36. So I have a negative 36, positive 36, that goes away. That's what I need to check. Again, this is a formula that you're going to memorize and probably forget at some point, and so you need to have a way to be able to check to get back to it. Let's go to sum of 2 cubes. Perfect cube 1, perfect cube 2a. My formula says if it's the sum of 2 cubes, I write the 2 perfect cubes there, cube roots. Square the first, square the last, multiply them together, write it. It's minus because plus minus plus. And you could rewrite this in a form we like 2a plus 1, 4a squared minus 2a plus 1. You could have rewrote that at the beginning to sum. The last two on here that I'm going to give you a hint about are these down here, which are some seriously good factoring. Factor out the greatest common factor, see what's left. Remember, any even power is a perfect square. So x to the 8th minus 1 could be x to the 4th minus 1, x to the 4th plus 1, and then this factors more. You can keep factoring down those differences. Same thing here, you can factor out a GCF. If you're left with any even power, you can write it as a difference of squares. So there's a few different examples. Again, go back to your original videos we watched if you need some more help.